Welcome back, you tricksters, you. Looking today, we are going to move a little bit forward, and it's been a while. We had a long weekend because of the snow day. I just want a quick, easy recall. What's trigonometry? Talk it out. I'm going to call on one random person. You missed me do some magic there, Huggins.
Oh, yeah?
Yeah. I'll do yours this afternoon.
My magic?
Yep, I'll do magic for you too. What is trig? That's the question at hand. Oh, you are almost at the end of the box. Yep. All right, coming back together. You guys remember your numbers? I found my list finally. I got to rewrite it. But let's see, there's 12 of us. I'm not going to be an answer in here. Let's check it out. I need to know, what is trig? Number 12. Triangles, right? It's the study of triangles. Now, up to this point, anytime we've dealt with those triangles, they've always been special triangles.
90 degrees.
They have been right triangles, which is really convenient because they're super handy. They show up all over the unit circle. Are there other triangles that aren't right? For sure there are. Do you remember what they're called? So isosceles, you could have an isosceles triangle be a right triangle, but they don't always have to be. Cool. So for this, we are just going to sneak ahead. We're going to start 6.1 today, and then we'll talk about what that triangle is actually called. I do not anticipate we're going to have homework yet. But check it out. 6.1.
Sorry, I assumed it would just be.
You want me to take your notes too? Just kidding. You can just take that pencil for now. You're good. Cool. 6.1. Our focus is we're going to take a little time machine back to geometry, I believe, where we will define this again in a moment, but we're going to be looking at the law of sines. Okay. Our law of sines. Now, I don't think it's a huge shock, but just so you're aware, law of sines is our first section. Any guess on the second section? Law of cosines. There is a law of tangents. It's so seldom used that we don't even cover it, but it does exist. Okay, the law of sines, the law of cosines, it relies on one big idea. We need a way to solve non-right triangles, or more appropriately named, oblique triangles. We have non-right, which I'll sneak that in as a vocab, non-right, and we'll just call those oblique triangles that normal trig doesn't cover. I'm just going to say 2. We get some oblique triangles. Now, we can't use Pythagorean theorem, which means to get those other sides of the triangle, we have some issues. So we need a new way to rely on this. Okay, to sort this out, I'm going to sketch a non-right triangle, and mine always wind up looking essentially the same, but they don't have to. I'm going to say, look at this lovely guy that doesn't have a right angle anywhere. Do you guys agree with it? There's no right angle here. Cool. Sketch one. And help me label points. We're just going to do a little bit of recall from geometry. I don't really care what side gets named what. Do you want to use A, B, and C? I lied. Let's use A, B, and C. Okay, so I'm just going to draw a non-right triangle. Cool. It could be equilateral. That is a non-right triangle. But here we go. I'm going to say A on the bottom left, Bravo B on the top, and Charlie C on the bottom right. Now, a little bit of recall from geometry, and I think I misspoke during a lesson earlier this year, so my bad on that. Capital letters typically indicate the point or the angle that we want. Now, if there's no ambiguity, which means it's like there's no confusion, don't draw this. I'm going to do it in red. I just want to talk about it. If I want to talk about this angle, I could talk about the measure of angle BAC. Do you guys agree with that? Is there an easier way that we can refer to it? Angle A, there's no ambiguity for it, right? Now, if there's ambiguity, use the points, or more commonly what I do is I would just put a number in here. I would rather not have to use all these letters while we're doing the geometry part of it. Okay, so we have 3 sides of a triangle. We've talked at least a little bit about how to name the angles or the points. If I have sides, which of course I must, right? It's a triangle. What should I call this side right here?
BC.
So you could call it BC as a segment. I'm not going to call it this, but absolutely, you could. Is there an alternative that you guys used in geometry? How do I differentiate between angle A and side A? Lowercase a. Which means this one sucks with C, but lowercase c. And then down here is lowercase b. Everybody cool with that? Okay. You are going to have just a litany of memories from geometry coming back to you here that you're going to associate with stuff. If I say SAS or SAS, what does that represent on a triangle? Side, angle, side. What about a saw? Angle, side, angle. Okay, how about ace? I don't know how you guys learned it in the first place. So that's S. We're not going to do that one. Angle, angle, side is how I say ace. That wasn't your geometry teacher. And there's one more. Side, side, side. Okay. Side, side, angle is the one that I'm going to call that. Or angle, side, side. That one is not a congruence rule. You guys may be, like, I'm sure you remember all these things. Side, angle, side helps you for triangle congruence. Is this triangle the exact same size and shape as the other? It also helps with similarity, which is just the shape part of it. Now, from here, we are going to be solving triangles like these. And this is where we're starting in. To solve a triangle, just remind me, it means that we're finding what? All right, remind each other and then remind me. What does it mean to solve a triangle?
Find all the sides.
All the sides and all the angles. Now, if we wanted to solve a triangle, I'm going to have to be given a little bit of information. But we're going to be looking at two different cases here that works super nicely for us. If this, we are going to be given some information. Given, and I'm just going to write these out. We'll say angle, side, angle, ASA. If you give me angle, side, angle, or angle, angle, side, and I'm going to switch colors intentionally here for this last one, or side, side, angle. If you give me any three pieces of information here in this order, we're allowed to use the law of sines, and it will work out for us. So given this stuff, we haven't defined it yet. We're going to say use law of sines. Now, this one, I write it SSA just so it doesn't look like we're just writing profanity here all the time. The other big part of it, though, you probably don't change colors. I want you to put asterisks or stars or something next to this one. That's the weird situation that we're going to have to deal with. Okay, we're going to use the law of sines. Now, certainly possible, and I would argue likely, anybody remember the law of sines? Something about it. Dig deep collectively. See if anybody can come up with anything chatting with another. Oh my Rafa. What did you just do? Something over something, that ratio is equal to something over something else is equal to another one still. Okay. If you guys want to prove it, we can. I'm fine with it. But we're just going to give ourselves the law of sines to begin with. So, to save just a Scotia time, let's get it. First big idea, and this is just a definition or a theorem, I guess, but we'll just actually define it for ourselves. I know it's redundant, but let's knock out the law of sines. Okay. Here we go. I'm going to write it out with words. We're going to draw a little picture of it. The picture is not going to be huge because you don't really have to draw the pictures, but let's make sense of this. If, or we'll say given, and if I want to write triangle ABC, do you guys remember doing it like this in geometry? Triangle ABC. Everybody, I imagine, saw it that way. Okay, you give me triangle ABC, and I'm not going to write it, but the sides are side A, B, and C, just lowercase, right? Okay, you give me that triangle, then, whether it's right or not, we get the following relationship. If you were to take the sine of angle A and divide it by the length of side A, it turns out that this is exactly equal to the sine of angle B What do you think we should divide that bad boy by? The length of side B. And it turns out that that is still equal to what? The sine of angle C divided by the length of side C. Now, for this, it is entirely up to you whether or not you want to write it, but this is true, and so are the reciprocals. If I flip each one of these upside down, so A over sine of A, B over sine of B, C over sine of C, then we still get this relationship. Okay, I'm not going to write them all down. I want you to keep that in mind, though, that the reciprocal also exists, because if we're finding for a side, I want the side on top rather than the denominator. It's always easier. Okay, I don't think we need to prove this, unless you guys are just dying to. Let's check it out. I'm not going to prove it. We can if you guys are feeling proofy. Let's just jump right in. Everybody remember seeing this as soon as we wrote it? Like, you might not remember using it a ton, but cool. All right, so I'm not going to name this one, not yet anyway, because I'm going to make you help me pick out the case. I'm going to draw us a nice, beautiful picture, and it's going to be the same triangle, like never to scale. I have a really hard time of making these not be right triangles when I draw them for whatever reason.
It's always the top one that I get 90 degrees.
Yep, but as long as you don't mark it as 90, it's fine. Like, it's not 90. All right, so I have this lovely triangle where I'll put A on the bottom left, B, Bravo on the bottom right, and Charlie up top. And we're just solving this triangle. I can write that here in just a moment, but I'm going to give us some lengths here. I am told that the following information, I'm going to make you label it. Side A, rather, is 32 units. I'm also told, and this is how it's going to present in your book. I don't love it, but I'll allow it as long as we can all agree that there's an obvious way to make the determination here of what's happening. I have this triangle, ABC, and whether we draw it or not, you don't have to draw it right off the top, but it does help, especially when we're starting it. Okay, I have these three things given. Could I label them on my picture as well? I think so, like pretty sure of it. Okay, beyond that, what I want you to make a habit of is, I'm going to keep that up as long as I can. If you're solving these, can you tell me, if we're solving this triangle, what are the three things that I'm after in the end? Say that again.
Side B.
Side B is approximately something. Side C is approximately something. And angle C. Now, I have no issues if we do it like this. It is much more correct. Your book doesn't do it. This is how it should be written. Measure of angle A. I'm okay with just using the capital letter as long as you include the degrees. It's clear we're talking about the angle. Okay. For this problem, do you want to do the first one together? Or do you want to try to work through this at your desks? Nobody wants it at their desk. Okay. Would labeling the picture help? Probably. So I'm just going to label it, and I'll switch to green for all my new stuff. Let's see. You tell me where to put the 32. 1, 2, 3. 2. All right. So here's my 32. It's awesome. Okay. The A looks like it's right here. I'm just going to put 30 degrees inside. And B is 45 degrees. So the first thing that we need to be able to identify in these situations is I listed up top above 3 possibilities that will rely on the law of sines. Which of these do we have? Do I have angle side side? Do I have angle angle side? Or do I have angle side angle? Angle angle side. Now it's weird when you're looking at it, and there's a little bit of strangeness that happens that hopefully that's been cleared up in geometry. But angle angle side, because I literally go from an angle to the next thing that I touch given is an angle, and the next thing that I touch is the side. If I had been given this, and I don't want you to change it, but let's say that that was where my 32 was, what do I have now? Angle side angle, because you always go to the nearest piece. Okay, cool. All right, so let's dig in. We are going to need some calculators for this, just so you're aware, because we're going to get some ugly numbers when we're doing law of sine stuff. Did it spill everywhere?
Made a 10.
It's like small.
Is it water?
Yeah.
Okay. All right. So I don't really have a preference on where we start. Could we find angle C relatively easy? I don't know what mode it's in. Thank you. How do I find C? Yeah, 30 and 45 makes 75. So 180 minus that, they have to add up to 180, right? It's a triangle. I think that's 105. I'm pretty confident that this is going to wind up being 105. Somebody should check my math. 105. Okay, they have to be supplementary, all three of them. 180. Everybody cool with saying 105 degrees and we're good? Awesome. Now, unfortunately, we don't have a right triangle to deal with, though. So here's the cool part. Remember what I said about those reciprocals, and you can flip them all. Am I trying to now find a side or an angle?
Side.
So I want the what in the numerator then?
Or side.
Okay, I'm going to make this comment in case that doesn't click. To find, and I don't care what side it is, to find a side, have the side length in the numerator. I'm going to call it up top because that's a shorter phrase. I want the length that I'm solving in the end to be in the numerator. Now, that is not required. You can do these problems if it's upside down, but you're going to have an extra step. Okay, from here, we're going to set this up. Let's find side B first, arbitrarily. I just randomly chose that side so you're aware. So if we want to find side B, for example, we'll do this first, and I'll just underline it. Okay, that means that if I write all this out, and you guys can plug in numbers, but I would take B over the sine of angle B equals, and I get my choice. Do I want to pick side length, the language is ugly, C over the sine of C, or should I use A over the sine of angle A? Why? Good. If I tried to do this, and I don't want you to write it because I just want to make sure we can see it. If I tried to do it this way, don't write it yet, Kalisha. This is true. 100% this is true as long as that's a capital C. However, check it out. We don't know B. What's side length C? Don't know it. We have an issue. We can't use this one to solve it. So if you run into that situation, it's easy to fix. Instead of side length C or C over the sine of angle C, what should I commit to? A over the sine of angle A. Okay, once we've identified the pieces we know, piece of cake. Let's check it.
Well, I don't understand why you're putting the A on and the B and the A, the side length on top now.
So because I could have it in the denominator, but then if I do that, I still have to cross multiply to get it out of the denominator. If I have 1/2 equals 2/4, then 2 is equal to 4 still, or 4 over 2. Like flip it. It's easier. Only because it's easier, it's faster. Okay, at this point, I wouldn't plug anything in as long as I'm aware that I have them. I'm going to do one step of algebra before I plug stuff in. I don't want to multiply by B. All I want over here is B. Right now I'm dividing it by what? The sine of angle B, which is just a what? Louder? Number. It's just an ugly number. This is like B over some terrible decimal. I don't want to write the terrible decimal. I'm going to multiply both sides by the sine of angle B so that I'm not cheating anything. We're doing the exact same thing. It's a property of equality. And I'm left with this lovely expression. B is apparently exactly equal to A times the sine of angle B divided by the sine of angle A. Notice equal sign because this is this is true. Now, the odds of us getting super nice stuff are pretty slim. We're not going to get really nice numbers, which means at this point, we're going to transition away from those lovely exact answers with square roots everywhere to what everybody hates is decimals. And the second that I do this, I'm going to change this sign. I'm just going to plug in what I know. This is 32 times the sine of 45 degrees all over the sine of 30 degrees. Now, I know both of those things. We could do exacts if you guys really want to, but they don't normally work out. On my next line then, I'm going to say B is approximately, and I want you guys, without any other guidance, get me an approximation for B. I'm expecting probably 2 answers, but maybe more. I don't have a calculator whatsoever, so feel free to shout them out. I'll just write them, and we'll see which one winds up being correct. Can you shout it louder? And then we're going to go to 10 thousandths, which is 4 decimal places. 47 point. Can you go 4 decimals? 228. One more.
8, 9.
Okay, so 2289. What's after the 9? 1? Okay, so 47.2289. We might have a different answer. Somebody else, I imagine, has a different one. I don't know the answer off the top of my head.
27.
So 27 is one option. And what was the other one? 45.2548. One of these is probably correct. Why are we getting different answers?
45.
Radians. Check your mode real quick. I have a feeling that you're in rads. Radians.
She's in 27 is radians. 45 is
I got something else too. I'm in degrees.
You're in degrees, and which answer did you get?
45.
Somebody second that.
Yeah.
Okay, so for this, that was for B, right? Cool. I'll go ahead and write it. We now have 45 point, what was it? 25? And I'm going to go all 4. 2548. 45.2548. Okay. And this, they are pretty computationally heavy. And there's some really cool stuff that winds up happening. I want you guys working together to also find me side C. Now, once I write this number, 45.2548, I'll write it up where we found it, 45.2548. When I do my next calculation, should I use that or should I use 32?
You should use the first one because the numbers are nicer.
I would use the first one that's not an approximation, the actual true given length of it. Okay, I want you guys to find me C. Based on the triangle that I'm looking at, it better be bigger than 45 and 32, like it needs to be. I'm checking the biggest angle across from the biggest side. Find me C using the law of sines. I will give you a moment. All right, I got you. I like your style. I want you guys to do homework this evening. We'll add to it tomorrow, but I want to see that you're done with it. See if you have questions, we can hit it. 7 through 9. This is page 408. I want 7 through 9. And we'll do 13. Cool.
Good thing I reminded you guys.
What's the E?
What's up?
What is the?
Oh,
7 through 9 and 13. All right, later Raiders, I will have your version 2s graded. Maybe at lunchtime, we'll see. I have some other stuff to do. All right, peace out.